Good day everyone! Again, this is Miss Elise to give you another knowledge about statistics and probability. We are now on the third video of this course. The topic on this video is normal distribution. But first, let us know the different learning competencies for this subject. The learner shall be able to illustrate the normal random variable and its characteristics, then construct a normal curve, then identifies region under the normal curve corresponding to different standard normal values. Fourth, converts normal random variable to a standard normal variable and vice versa. Lastly, computes probabilities and percentiles using the standard normal table. Let us have an idea about the two words that made up our topic, starting with the word normal. When we say normal, it will be standard, expected, typical, or usual. While distribution can be a table, flow of information, supplying tasks or deliveries, and a graph. Combining the idea of the two words, then we will have normal distribution. So what is normal distribution? The normal distribution is a probability function that describes how the values of a variable are distributed. It is a symmetric distribution where most of the observation cluster around the central peak and the probabilities for values further away from the mean taper off equally in both directions. The graphical representation of normal distribution is called a normal curve. It can also be called as bell curve because of the shape of its graph. It is an extremely important statistical data distribution pattern occurring in many natural phenomena such as blood pressure, machine parts, human height, error in measurement, IQ scores, lifespan of light bulbs, weights of loaves of bread, and many more. To understand more about normal distribution, let us study its characteristics. Generally speaking, normal distribution has 5 characteristics. The first characteristic is the normal distribution is a mathematical model represented by a bell-shaped curve which is symmetric with respect to the mean. As you can see, the green line segment on the picture divides the graph into two identical parts. The second one is the mean, median, and mode of the normal distribution are equal. If the mean, median, and mode are equal to each other, the distribution is symmetrical. This supports the first characteristics. The third one is the normal curve approaches but never touches the x-axis, as it extends farther and farther away from the mean, meaning that even how long the curve extends on both directions, it will never intersect the x-axis. The fourth one is the area under the normal curve is approximately equal to 1 or 100%. And last one, the standard normal distribution has a mean of 0 and a standard deviation of 1. Do not forget this characteristic, for this is important on the following things that I'll discuss. Let us now discuss how to find the normal curve area and probability. In order to find them, a z-table is an important tool. A z-table, also called the standard normal table, is a mathematical table that allows us to know the percentage of values because below a z-score in standard normal distribution. This is the z-table. Entries in the z-table give the area under the curve between the mean and the z-standard deviation above the mean. So, how will we find the area under the curve given a z-value? Let's follow these steps and reminders to find the area of a given z-value. Let's have 1.62 as an example. Most of the time, z-value has 3 digits. To know the area, first, determine the first 2 digits of the z-value and locate it on the leftmost column. In our given, the two digits are 1 and 6, and it is located here. The second step is determine the third digit of the z-value and locate it on the topmost row. So, we have 2 for the third digit, and it's right here. The third step is to find the intersection of value from step 1 and step 2. So the intersection here is 0.4474. This is already the area between the z-value and the mean. The last step is to find the normal probability by multiplying the area by 100%. So the normal probability of 1.62 is 44.74%. Did you get it? Let's have another example. Our given z-value now is 2.79. The first two digits here are 2 and 7. And it is located here. The third digit here is 9. And it's located right here. Now, the intersection of the values from step 1 and step 2 are 0.4974. This is already our area, and multiplying it by 100%, the normal probability is 49.74%. Easy, right? Let's have another one. Our given z-value now is 3.0. The first two digits are 3 and 0. And it's located here. Though we don't have visible third digit on the given, remember that it will be 0. So it is right here. Now, the intersection of the values from step 1 and step 2 are 0.4987. This is already your area. Then multiplying it by 100%, the normal probability is 49.87%. I'm pretty sure that you already have the idea of determining the area and normal probability given a z-value and z-table. Now, there are different situations that may arise when asked to find the normal probabilities. And here are the 5 different situations involving normal probabilities. The first situation is between 0 and any z-value. The instruction given is to find its normal probability is to look for the area of the non-zero value in the z-table. Let's have an example. Find the probability between 0 and z is equal to 0.5. And here it's graph. Let's find the area of 0.5. First two digits are 0 and 5. And 0. Since there's no visible third digit, then find the intersection and we'll have 0.1915. Multiplying it by 100%, we will have 19.15%. Did you understand it? Now, let's proceed to the second situation, and it's about having two z-values with the same sign, and to find the normal probability, we just need to find the areas of the given values and subtract the smaller to the larger area. Let's have an example for this. Find the probability of z-value is equal to 1.27 and another z-value is equal to 2.3. Then the graph will be like this. Let's find the areas of the two z-values. The area of 1.27 is 0.3980, while the area of 2.3 is 0.4893. Subtracting from 0.3980 to 0.4893 will give us 0.0913. and multiplying the difference by 100%, the normal probability between 1.27 and 2.3 is 9.13%. Let's proceed to the third situation. In here, we are having two values with a like sign. So to find the normal probability, we need to determine the areas of the given values, then add them together. Here's the example for this. Find the probability between negative 0.13 and 1.3. Let's find the areas of the two z values. As you can see, the first one is negative z value, but do not be confused on this because we just need to disregard the negative sign in finding its area. So the area is for negative 0.13 is 0.0517, while the area for 1.3 is 0.4032. Adding the two areas will give us 0.4549. Then multiplying by 100%, the normal probability between negative 0.13 and 1.3 is 45.49%. Got it? Let's proceed to the next situation. There will be two scenarios on this situation. It can be finding the probability of z values less than a particular negative value, or finding the probability of z values greater than a particular positive value. But the instruction on the both scenarios are the same. We need to look for the area of the given value and subtract it from 0.5. Let's have an example. Find the probability less than negative 1.43. To answer this, again, let's find the area of the given. The area of negative 1.43 is 0.4236. Then, subtract it from 0.5, that will give us 0.0764. Then, multiplying it by 100% to get the normal probability. So, we will have 7.64%. And that's the normal probability of values less than negative 1.43. And for the last situation, just like the fourth situation, this one has two scenarios. It can be finding the probability of z values greater than a particular negative value, or finding the probability of z values less than a particular positive value. But still, the instruction on both scenarios are the same. We need to look for the area of the given value and add 0.5. Let's have an example. Find the probability greater than negative 1.63. Again, let's find the area of the given. The area of negative 1.63 is 0.4484. Then add 0.5, that will give us 0.9485. Then multiply by 100% to get the normal probability. So 0.9485 multiplied by 100% is 94.85%. And that's the normal probability of values greater than negative 1.63. So this is the summary of the different situations that may appear when asked to find the normal probability. So don't forget this information. So that's for today. Thank you for watching. Please share and subscribe. MATHerrific, learning materials for math and physics.